Happy Friday, everyone. Today we're going to take a look at, final forms of factoring. So in addition to the box method we've been using, there are other forms of factoring which use a term you're probably familiar with, the greatest common factor. All that is really the biggest multiple shared by two different numbers. So in this case, I've got 45 and 36. So all I'm going to do is I'm going to list the factors of each one. So if I've got 45, I know I've got 1 in 45. I know I have 3 times 15 is 45. And I know I have 5 times 9 is 45. If I take a look at 36, I've got 1 in 36, got 2 in 18, 3 in 12, 4 in 9, and 6 in 6. So then I'm looking through all of the factors and finding out which of them is the largest factor that they both share in common. So when I look through this list, I notice that 9 is the biggest number they share in common. So the way I often write that is saying the GCF of 45 and 36 is 9. So that's it. Find out what numbers multiply to get 45 and 36 in this case, and then look through the list and identify the largest number they share in common. So over here, I'm going to do the same thing, but I chose this one because it's a bit of a special case. So the numbers that multiply to get us 10 are 1 and 10, 2 and 5. And for 20, it's going to be 1 and 20, 2 and 10, 4 and 5. So the reason I say that this one is a special case is because it turns out that the largest factor they share in common is actually one of my two original numbers. So in this case, 10. So that's totally possible. Just wanted to make sure that possibility was clear. All right. So the greatest common factor for 10 and 20 happens to be 10. All right, we're going to use these two facts for the next piece, which is factoring completely. That term completely is really important here. So notice how in this case, I have a 45 and a 36, and we identified before that 9 is their greatest common factor. So when I factor completely, I basically want to divide both of these by 9. And if you notice, for 45, the factor pair with 9 is 5. And for 36, the factor pair with 9 is 4. And so when I say factor completely, I notice that they both have a factor of 9. And so I'm going to pull that out. And there's my factored form. What I encourage for these is that you do a check. So if I write down my factored form, what is 9 times 5x? That's 45x. And what is 9 times 4? 36. That matches my original. So I know that my factoring is good. All right. This one's just a little bit more complicated, but the same ideas apply. So notice how there's a 10 and a minus 20. And I know the greatest common factor of 10 and 20 is 10. Then I'm going to go up here and say the factor pair with 10 is 1. And the factor pair here for 10 is 2. But also notice how there's an x squared and an x. Well, if that variable shows up in two terms, I can factor that out too. So first, let's start simple. We're going to take 10 out of both of these. That's going to give me 1x squared minus 2x. But this isn't factored completely yet because, once again, there's an x in both of these. And so x squared really means x times x. And here, this is just x. So I can pull an x out of both of these. Should leave me a 1x minus 2. Or that 1x is not necessary. I could just leave it like this. Both of those are good. I like this one because it's nicer to read, but this one's good too. All right. So once again, I'm going to perform a check real quick. So if I take that 10x times x minus 2, 10x times x, if it helps, think of that 1 being in front. So 10 times 1 is 10. X times x is x squared. And then 10x times negative 2 will be minus 20x. All right, those two things look just like my original. So I'm good to go. Now I know that that must be my factored form. That's it. All right. So the very last piece here is going to build on what we were doing earlier this week. The greatest common factor is going to play a role here. So I'm going to look at the factors of 2. Just 1 and 2. Factors of 6 are 1 and 6, 2 and 3. All right, 108 is a scary number, but it's not so bad. 1 and 108, 2 and 54, 3 and 36, 4 and 27, and then we got 9 and 12. All right, so if we look through all the factors, well, the biggest factor here is 2. I see a 2, I see a 2. All right, so there's our greatest common factor, a 2. So I'm going to factor out a 2 from all of these terms. So notice how the pair with 2 here is 3. So I'm going to have plus 3x. And the pair here with 2 is 54. So I'll have a minus 54. All right. The nice thing about this is this gives me a much easier trinomial to factor than what I had before. So now I'm going to make a box, and I'm going to try to factor this. So remember, the idea here is to factor completely. So even though I took a 2 out, I'm not done yet because I can still factor what's left. So I'm going to put my x squared in here. I'm going to put my negative 54 in here. I know this has to be x times x. The question is, what are the factors of negative 54? So we got 1 and 54, 2 and 27, 3 and 18. And we've got 9 and 6. But remember, since this is negative, I know that whenever I pick one of these pairs, one of them has to be a negative number. Well, as I look through, if one of them's negative, the only one that looks like it might get remotely close to positive 3 is this 9 and 6. I know it needs to be a positive 3, so I'm thinking maybe the 9 should be positive and the 6 should be negative. So I'm going to give that a go. All right, x times positive 9x, negative 6 times x, negative 6x. All right, so here's all my stuff. Let's give it a look. Some of you probably already see it, but if you don't, it's always great to write down the steps. I see positive 9x minus 6x. Sure enough, those combine to get me positive 3x minus 54. This seems to match this. So that's great. We'll check mark that. So that means here are my two factors that work. So my final answer then is going to be this. So the whole idea is first look at your original expression. See if you can pull out a number if all of these terms share a common factor, which in this case was 2. So I just took out a 2 and divided all these things by 2. Here's what was left. Now I know how to factor that with my box method, so I did. And so now that 2 is being paired with the 2 factors of that trinomial. Once again, I always write down all of my steps. Some of you have shortcuts that work, so maybe you don't need to create all of this, or maybe you do. It's all about identifying what works best for you as a learner. All right, in this case, I've got a 5. The only factors are 1 and 5. I've got a 30. So those factors are 1 and 30. By the way, I know this is a negative, but right now I'm just worried about the factors of the 30. We'll deal with the negative later. 2 and 15, 3 and 10, 5 and 6. And then finally, we've got 40, 1 and 40, 2 and 20, 4 and 10, or 5 and 8. All right, well, the biggest factor for 5 is 5, and I see a 5 in each of these cases. So there's my greatest common factor. So the pair is 1, the pair is 6, the pair is 8. So in other words, once I divide all those terms by 5, there we have it. And you can always do your check. What's 5 times x squared? It's 5x squared. What's 5 times negative 6? It's negative 30. And what's 5 times positive 8? It's positive 40. Cool, I'm good to go. I know I've at least factored out the number correctly. Now it's just take a look at our box. All right, we know we're going to have an x squared. We know we're going to have a positive 8. This one's a bit of a unique challenge because there's a negative 6, but I think we can handle it. So we know x and x should work for x squared. And then here, that plus 8, I'm going to think about, and I'm going to say factors are 2 and 4, 1 and 8. Well, I know my factors need to combine to get me a negative 6. 1 and 8 doesn't really look like it might do that. 2 and 4, how are 2 and 4 going to get us a negative 6? Well, I think the important thing is remember that a negative times a negative is also a positive. And so maybe plus 2 plus 4 won't work, but maybe minus 4 and minus 2 will work. Because once again, negative 2 times negative 4 is positive 8, so we've checked off that one. Now negative 2 times x, negative 2x. X times negative 4 is negative 4x. We've got all our terms. I think I'm seeing that it's going to work, but let's just verify. Okay, negative 2 minus 4 more. Sure enough, takes us to negative 6x. We have a plus 8. This matches this. We're in good shape. So now we've got our 2 factors right here. And we also have that 5. So we know that our final factored form, our complete factored form, is going to be this. All right, and those are all the big pieces. So basically we're just doing everything that happened over the last few days and taking it one step further by saying, before we do anything, is there a number that we can take out of the original expression that actually makes our factoring a lot easier? If we can do that, do it, and then wrap up factoring like normal. All right, with that said, good luck. Let me know if you have questions, and we'll talk soon.